Hello, this is HK Math, and I would like to share with you a brief tutorial on how to multiply polynomials using chunking and the distributive property. Chunking and the distributive property. So let's start with a binomial x plus 3, and we're going to multiply that to a trinomial, x squared plus 5x plus 6. We're multiplying this trinomial times this binomial. And you can note that this is one of the Common Core standards for Algebra 1, arithmetic with polynomials and rational expressions. And this is the standard that we're addressing. The A stands for arithmetic, the P stands for polynomial, and the R stands for rational expressions. Let's find our chunk. We're going to think of this whole quantity, x plus 3, as our chunk. And we're going to distribute that chunk across this trinomial. So the chunk is being multiplied to the x squared. That same chunk is being multiplied to the 5x. And that same chunk is being multiplied to the 6. Now let's see what we get. We get the quantity x plus 3 times x squared plus the quantity x plus 3 times 5x plus the quantity x plus 3 times 6. And now we're going to do some more chunking. We're going to look at this quadratic term as a chunk. We're going to look at this linear term as a chunk. And we're going to look at this constant term as a chunk. And we're going to take this chunk and distribute it over this quantity and over this quantity. We're going to take this chunk and distribute it over this quantity and this quantity. And we're going to take this last chunk and distribute it over the x and the 3. And I think I'll go back over here. And no, I better stay where I am. The x squared times the x is x to the 3rd power. The x squared times the 3 is 3x squared. Now, the 5x times the x is 5x squared. The 5x multiplied by 3 is 15x. Now our last distribution, 6 times x is 6x plus 6 times 3 is 18. So now we're ready to collect like terms. The 3x squared and the 5x squared are like terms. The 15x and the 6x are also like terms. So let's add our entire polynomial together. And we get x to the third power plus 8x squared plus 21x plus 18. All right, and that is our answer. Now, I'd like to take a special look at this problem when x takes on a value of 10. So let's look at x equaling 10. And I'm taking on that value because our number system is based on 10. So if we let x equal 10, then our x plus 3 is 13. And our x squared plus 5x plus 6 is 156. So under certain conditions, when x is 10, we're really multiplying 13 times 156. Now let's see what that equals. 13 times 156. I'm going to do that the way we learned back in the grade. 3 times 6 is 18, carry a 1. 3 times 5 is 15, and the 1 we carried makes 16. 3 times 1 is 3, and the 1 we carried is 4. And then we simply place the other digits because we're multiplying by 1. And our answer is 8 to 2028. Does that 2028 have anything at all to do with the term we found as our answer? And boy, is this getting cluttered. Hope you can follow what I'm doing here. Well, let's see. I'm going back to what we discovered as our answer, but I'm only looking at it when x is 10. So x cubed becomes 1,000. 8x squared becomes 800. 21x becomes 210. And 18 becomes 18. And if we add all of that together, wow, look at this. We're getting 2028. This stuff actually works for real numbers. Why did I pick 10? Because our number system is based on 10. And plus, working with 10 makes this easy to prove. I could have used the 9. I could have used the 99. I used the 10 to show you that all of these terms here represent real numbers, that x cubed is a number. If we want it to be, And so it's the 8x squared, the 21x plus the 18. We can add this together and all of it will represent a number. So this was a somewhat long tutorial. I hope you were able to stick with me long enough to see that chunking can work in many, many different situations. We have used it to solve two-step linear equations. We have used it to solve absolute value equations. We are now using it today to multiply polynomials. This can be used in a variety of ways. I love chunking. Hope you do too. Until next time, bye now.